In this problem, we're given this power transmission line tower. I've just drawn the top of it here because we actually don't need the bottom of it because we don't need the reaction forces that between it and the ground. So we can just draw a free body diagram at the top, and what we're looking for is there's these cross members throughout the structure, and we're told that they can only be in tension. And so we're asked to look at the ones in the second section from the top here, to see which one of these, what the forces are in these two members, and knowing that they have to both, or that they cannot be negative. So we can write force vectors. These are the external loads acting from the transmission lines, and the internal loads here from where we cut across the structure. And we can sum the forces and then sum the moments, and I picked this as my origin here. And again, I can write these as vectors, just like we did in all the previous problems. And we wind up with these three equations if we sum the forces and sum the moments. And so what we need to do, we have four unknowns in these equations. So the problem is obviously we can't find four unknowns with only three equations, but we can make the assumption that one of these is 0, and then check what the other one is. And so if we assume that this member from C to J is 0, we find that the member from E to H has a negative force in it, which means it's in compression. So that is not the correct assumption. So we can assume that the member E to H has 0 tension in it, and then find the tension in CJ, or the force, and it is positive, and it's 1.03 kilonewtons. So this is our answer here. There is 0. This is carrying no load, and this one is in tension.